Hi class. So today I would like to talk about small modular reactors and the role it plays in future energy, focusing specifically on the growing technological advancement and its role that's going to play in eliminating fossil fuels from energy production. To start with my agenda, I'm going to first introduce what SMRs are, then I'm going to go about my bullet points on why this is going to be so impactful for the future, starting with the scalability of the SMRs, the economic growth opportunities that come with it, and the environmental impact that nuclear energy will have on the environment. Then I'll conclude my presentation. So to start, what are small modular reactors? These are compact nuclear reactors, and they produce up to 300 megawatts worth of power. And these are significantly smaller than traditional nuclear plants. And then the last bullet point I want to talk about is the design to be scalable and adaptable to different locations. This is probably the most important component of it because now we're able to get nuclear power to these isolated or smaller towns where traditionally that these massive plants haven't been able to do. So why are these important? So they provide a potential solution to phasing out fossil fuels, which I've already brought up. But like I was saying, fossil fuels have been such an important part, but we know the world is going to a more sustainable future in energy production. And then lastly, to complement renewable energy sources like wind and solar. So we know from learning in class that wind and solar is very dependent on the environment. So like nighttime solar wouldn't be a very productive energy source. So these SMRs are going to be a very good baseline and support for these energy sources, as well as it has the ability to be a variable source output. So to bring up the scalability of SMRs, SMRs are about a quarter to a tenth of the size of traditional nuclear plants, but giving up size means you're also giving up power. So they're also going to be up to only 300 megawatts worth of power, whereas a traditional nuclear plant can do anywhere from, let's say, 700 to 1200 megawatts worth of power. But that's okay because not every city or every area has the same demand. As you can see on the image on the right, that the traditional power plants are mainly used for like major metropolitan areas, whereas small modular reactors is for like suburb cities, and then you see micro reactors on the very far end for a more isolated area, as you see like in these mountains. So when looking at the size and power output, you're also going to compare the cost. So SMRs are going to be roughly about $303 million, whereas a traditional plant is going to be $5.5 billion. That's going to be very impactful in the scalability and the use of SMRs when these smaller cities like suburbs or like isolated areas such as like third world countries and stuff are starting to look for like more traditional clean energy. And the last bullet point that I want to bring up with scalability is the prefabricated aspect. So these are all assembled within a manufacturing plant and transported to locations and are assembled on site. So this is going to be very much more beneficial than a traditional plant, having to have all of these construction crews and stuff going building from scratch on site, whereas a small modular reactor's assembly time is significantly less. Next point I want to bring up is the economic growth opportunities. So we know how important nuclear is and the risks that are associated with it. So when you're talking about SMRs, there's been extensive research and development that go into this technology. So that's leading to a lot of high skilled jobs such as scientists, engineers, and politicians that go into regulating this. So you're gonna have a lot of job opportunities come from that. And then as well, I've talked about the prefabricated aspect of SMRs. So you're gonna have a lot of manufacturing, transportation, assembly of SMR components. So you're gonna have these assembly line workers that are building the components. You're gonna have truckers, trains, boats that are moving it to the location that's desired, and then you're gonna have the assembly team building it on site. So that's going to create for significant opportunities as nuclear is already a very large industry as it is. Whereas, according to the Department of Energy, that there's already 60,000 jobs within nuclear, and these are just mainly your traditional plants. So when you start including these small modular reactors that are going to grow in technology, it's going to just skyrocket the opportunities for that. The next bullet point I want to bring up is the environmental impact that this is going to have. So we know that traditional fossil fuels are leading to a lot of carbon emissions. So we know that nuclear energy is a zero emission energy source. So this is going to be massive when this technology ends up being more adopted by these cities and countries. So nuclear energy helps reduce carbon emissions. In 2020, there was 471 million metric tons of CO2 saved in the U.S. alone. And actually, a study was done by the Nuclear Energy Agency that if their assumptions are met, there could be up to 87 gigatons of carbon emissions saved by 2050. So what these assumptions are is that anywhere from 50 to 150 gigawatts worth of energy is being installed by SMRs starting in 2035. So that's what you see here, where this little light blue shade is in the chart of that installed energy, and then this dash gray bar is going to be your emissions that are avoided from SMRs. To continue more a little bit on the environmental impact, I wanted to bring up the footprint of these SMRs. So, like I was already saying before, SMRs are significantly smaller than your traditional nuclear plants. In fact, just to reiterate, 1/10 of the size. But on top of that, they are also able to be buried partially underground. So if you look at this image on the left-hand side, you'll see that roughly about 50% of this little plant is underground. So it's not as much as an eyesore to the top of the land, and it's a lot smaller. Another bullet point I want to bring up is the safety and reliability. So there is a lot of pushback and concerns when it talks about nuclear energy, mainly because of past experiences like Chernobyl and 3 Mile Island. But these SMRs have been created and technology has gotten more advanced to where these have passive safety features. Whereas if certain things were to get over a certain temperature, that basic physics will cool down the reactor, so you're not gonna have any kind of catastrophes like there was in the past. So to wrap it up, I want to conclude that the SMR scalability allows to be implemented in various locations. So we're going to see a lot of growing within nuclear energy that hasn't been able to been doing in the past with traditional reactors. The job opportunities are created through rising demand. I know that if when you're trying to phase out fossil fuels and energy resource, that can have an impact on traditional like energy, oil and gas. But SMR is bringing a lot of opportunity with that. And then lastly, the clean energy versus fossil fuels. Like I was saying, the world is going to a more sustainable future, and these SMRs create the opportunity to wide scale nuclear energy and create that zero emissions resource. So thank you all.